I is equal to the integral negative infinity to infinity of e to the power of negative x squared dx. This is the bell curve. It is the most important shape in statistics, physics, and nature. But there is a massive problem here. If you try to calculate the area under this curve using standard calculus, you'll fail. There is no formula for the antiderivative of e to the power of negative x squared. It's a mathematical dead end. To solve it, we have to do something radical. We have to step outside of our 1D line and look at the problem from 3D space. Instead of solving for I here, we can solve for I squared. This will allow us to multiply the integral by itself, but we'll use a different variable for the second one. So we can say that I squared is equal to integral e to the power of negative x squared dx times integral e to the power of negative y squared dy. When we combine them, we aren't just looking at a line anymore. We're looking at a 3D surface, a mountain made of math. And then we know that this can be simplified. This will equal to integral infinity, negative infinity to infinity times integral negative infinity to infinity of e to the power of negative x squared plus y squared dx dy. So the move here is that rectangular coordinates x, y make this impossible. But look at that x squared plus y squared, that's the equation of a circle. If you switch to polar coordinates using radius r and angle theta, the entire problem collapses. Our x squared plus y squared becomes r squared, and our tiny area dx times dy becomes r dr d theta. The integral transforms into I squared is equal to 0 to 2 pi times 0 to infinity e to the power of negative r squared r dr d theta. Because of that extra r we gained from the coordinate shift, we can now use a simple u substitution. The inner integral becomes exactly 1/2, and multiply that by the full rotation of the circle 2 pi, and we can get I squared is equal to 2 pi times 1/2 equals 2 pi. So then I will just equal to square root of pi. So we solved the 1D problem by jumping into 2D space, which is a reminder that sometimes the answer is not in front of you, it's above you. So hit the like button if you love the smell of calculus in the morning, and subscribe for more mathematical leaps. What should we integrate next? Thank you for listening.